So translations in a coordinate plane are just a little bit different. So in this case, you're given something called the vector in what's called vector notation, where it's got this little arrowed bracket, and A and B, where A is the change in the x-coordinate, B is the change in the y-coordinate. All you have to do is add those numbers to the x and y coordinates. So if the x and y coordinate like this here, for P is -2, 3, and your vector is 7, 4, and you add 7 and -2 to get 5, you add 3 and 4, you get 7. It's that simple, just adding. So here we are given this triangle and our vector. There's a couple of different ways we could do this. We could write it out, or we could actually just change it based off what's happening, right? A vector of -3, 2 means it's going to the left 3 and up 2. So we do it that way too. But sometimes you want to write it out as well. So for t, we're at -1, -4, and that goes to t prime. So -1 plus -3 is -4, and -4 plus 2 is -2. For u, we're at 6, 2. And v, I'm going to write this down, -5, or 5, -5. For u prime, we are at, so 6 plus -3 is 3, 2 plus 2 is 4. And v prime, 5 plus -3 is 2, -5 plus 2 is -3. So 2, -3. So once again, though, we can use the vector whenever you're given it in the graph to figure out the graph just by moving over that much. So again, you're going to shift 3 to the left and 2 up. So my u prime is right there. And if we look at our, like the coordinate we got, 3, 4, it's exactly where we are, right? So we don't have to do it the way we did it before. For v, same thing, right? You go to the left, 1, 2, 3, up, 1, 2, and that point should be our v prime, which is at 2, -3, as written before. And then, of course, the last one, we're just going to plot the point, -4, -2. There's our t prime. And now we just need to connect our points. And there's our new triangle. Now we got one for you to try.